week 5, I believe everyone should be able to remember that we have to go back to campus. So this is week 4, the last week where we are doing fully online. Okay. If you're not sure anything to ask, you can clarify with faculty, or you can ask your course coordinator, or you can PM me, right? For the general questions, you can post in the GC. But if there is any personal matter, because I received some email from students about personal matter that regarding to hybrid classes and also other matter, so I will ask you to proceed to faculty, or also ask your parents or whatever to call up faculty and so on, because we have certain limit. As lecturer, we can't promise everything. It's out of our authority. We cannot do that. So we have to ask your parents or whatever to seek advice, and also the cooperation with the faculty. Okay. Other than that, the general matter we can answer you. We will reply your email. All right. So I hope everyone take note. Next week onwards. So far, we still haven't received any notice. We proceed with the hybrid classes. I'm sure everyone know your group A, group B, right? And for the lecture, I'm also still waiting for the final instructions from your faculty. So far, there is none, and therefore we proceed with this what we call it, hybrid classes. Okay, if there's any latest ruling. If not, then we go for the online for the lecture. Right, for the tutorial, we proceed with the hybrid. Okay, anyone want to ask any questions? Okay, I hope everyone already come back from Chinese New Year. You still can celebrate, but hopefully your focus is back to these classes and also your other subjects, because we will have our very soon assessment in week 7. Some of the subject I was told also in week 6 . So you have to take note of all the, what do you call whatever is already mentioned by your respective lecturer. So take note, do not miss the assessment for all exam or test or quiz. Okay. The other thing is this for precaution, safety purpose, I hope everyone have got your vaccinations and also your booster if you can, because as I say, it's for safety precaution for yourself and for everyone. Try to arrange it. If you need help, or as I said, you need advice or consultations, call the faculty or the officers, or you can ask a lecturer opinion. But we will answer you whatever we can. Right. So the first thing is the vaccinations, and then the second thing is, as I said, take note of all the tools that you need to bring into your campus after this, especially the laptop. We're still using laptop definitely, because it's hybrid. So I prefer to still use the laptop block, and if you can, you have the earphone. Okay, no need to buy the expensive one, just a small earphone. Cheaper earphone, which you can use it to listen focusedly on the lecture and tutorial. That's it. Right. So the different lecturer may use slightly different method. Okay, some may use webcam, some may use mic and so on. And of course, everything will be very limited because of the SOP. And don't forget to bring your mask. Wear mask if you can. Advice is to wear, some people say double mask if you can, or you use the better quality of mask and then bring sanitizer, so that for safety precautions. So you just go there and listen, okay, listen, and as I said, bring your earphone for better listening. All right. So any more questions from anyone before I start our chapter 2B? Nothing, class rep, who's the class rep area? There are 8 groups here, right? If I'm not mistaken. Everything need to recall back. So I hope your groups in the tutorial also doing fine. Any questions, you can ask your tutor to refer to me. So if there's no questions, we'll start our chapter 2B. Now, just right before our holiday, right, we have covered chapter 1 and 2A. I hope everyone have proceeded with your tutorial and should be able to finish discussing that, okay, and practice more. As I said, the coming assessment, you need to know how to answer the questions and so on, right? So I will start my tutorial 2B. I will do the recording again. If any of you still have anything to ask, you can PM me later. Yeah. Okay, measure of dispersion. This is part B. Remember, before the holiday, we have covered the part A when we talk about what mean, median, and mode, right? We have a few formula to calculate the mean, median, mode for raw data and also for group data. I hope everyone is still remember what is raw data and group data. And then we also have discovered a few methods to how to draw the histogram, right? And for the object, where histogram can be used also to estimate the mode, and object can be used to estimate the median beside the formula. Okay, so for today, we are going to look at dispersions, which is different from mean, median, and mode. Now, if you know what is dispersions, and if you recall back what I mentioned in the chapter 2A about the skewness, remember we talk about we draw histogram? Remember or not? This is histogram, right? Something like this. Let's say I give you an example. So you want to know how much the data, the distribution of data can be spread, or we call it variability. Spread means you want to see how much. Let's say this is your mean. Remember, this is your highest histogram. And remember that if you draw this normal curve, remember this is a normal curve. This is a normal curve. Many of you already know what is normal curve, right? So if you see this curve with the left and right tail, talk about skewness. Everyone still remember this chapter? There are two types, positive and negative skewness, right? And there's one symmetry. I hope you all know what is that. You can go back to your notes again. So when we talk about spread, we always measure to the center tendency. And want to see, we compare how much the dispersion from the various sample. So we want to compare the dispersion. We want to see whether the dispersion is high, low, or slightly high, and so on. Okay. Two data sets can have the same mean, median, or the mode, but they are very different in other aspects. So we need to check dispersions. Why we need to check dispersions? Okay, the reason is two sets of data can have the same mean, median, and mode, but they're actually different. Okay, give you an example. Consider the heights of 5 employees. Let's see one example. Why we have to study the spread, or we call it dispersions of data. So let's say I have two departments. One is called sales department, and one is called production department. Right? You know department, right? It's like an officer. So this one in charge of sales, this one in charge of production, let's say. So we have 5 employees. Now, sales department got 5 employees. 1, 2, 3, 4, 5. The heights in centimeter is 175, 176, 178, 178, and 183. This is the 5 persons height. Now, everyone, can I give you few seconds? You calculate the mean for me for sales department. Based on this 5 employees height, calculate the mean for me, state the mode and the median. Then for another department, another office department, let's call production. This is also another 5 persons employee height, 158, 178, 178, 180, and 186. Okay, can you all tell me what's the mean, state the mode and the median? Okay, can I give you about 15 seconds? Enough or not? Okay, everyone. Hua Chen Yi, mean for the sales department 178. Am I right here? You know how to calculate mean, right? Total divided by 5, raw data. Mode, eh? Mode is just the only, right? What's mode for raw data? Highest, most occurred, 178 month, right? Median, 178, yes. Remember to arrange first, right? Small to big arrange already. So the middle one is 1, 2, 3, 4, 5. Number 3, 178. Okay, how about production department? What's the mean? Total divided by 5. 178 also. Mode, also 178, 2 occurrence. Median, arrange already. Median is half. Third, 178 also. Everyone, you see, there are 2 departments here. I don't care lah. It can be 3 departments, 5 departments, 10 departments in the office, right? So you can see there are different 2 or more data sets. In fact, you can say 2 or more data sets can have the same mean. Same mean also same, mode also same, median also same. Correct or not? So I don't care whether there are 3 or 4 or 10 departments, but they are different in other respects. Let's look at here. So the distribution of the 2 data sets differ. You see, these 2 sets, let's talk about these 2 department is different. How to see this? To describe the difference quantitatively, remember quantitative means chapter 1, right? We talk about in numbers. We use a measure of dispersions. So you can see that even though the mean, mode, and median is the same, but the distributions are different. And how we know it's different? We look at the measure of dispersions. Later, when you learn this one, then you come back to here, you compare with these 2 sets of data. Even though, again, mean, median, mode is the same, but the dispersions are totally different. So you may ask, what is measure of dispersions? So let's start. The most commonly used dispersions are range, number 1. We are going through one by one now, everyone. So pay attention. There are a lot of formula in this chapter. Okay. Number 2, we are going to calculate quartile deviations. We call it QD. Then variance. Number 3, we use the short form VAR. Number 4, standard deviation, SD. And number 5, coefficients of variation, CV. One by one, we are going through it. Look at the formula, how to calculate. And remember, we have 2 types of data, raw data and group data. Remember? So we're going to look at each method times 2. So altogether, there are 10 formulas. Some can be simple, some can be challenging. Depends on whether it's a raw data or group data. So altogether 10 methods to calculate. All right. Now, the more spread, or we call it the dispersed data, the larger is the dispersions. So one of the spread that you all learn by using skewness, this is with the histogram and the normal curve, right? In future, when you do your research or whatever, you can always combine together. Histogram, you already have seen a lot more, right? Everyone already know how to draw using the scale and also the graph paper. So what you need to do is you have to learn to use software to get the skewness up, okay? Usually the software will calculate the skewness for us. So how much spread is depends on the distributions. The larger the data, the reading, the measurement means the larger is the spread. So let me talk about the spread for a better understanding. Okay, before we go through one by one here, right? So let's say this is the normal curve. Everyone have seen this before, right? What do you call this curve? Anyone haven't seen this curve before? Don't worry. Okay, if you can find any statistics book, the most basic one, even in your modern maths or MS, you may have seen this before. Okay, so where you use the normal table to find the probability, okay. Anyway, we're going to touch this a lot in chapter 4. So, but now I explain to everyone first what is meaning called spread. Now, remember this is the left tail. Okay, left tail. This is your right tail. So imagine this is your histogram. You draw the histogram, something like this. Remember I showed you before. Okay. Now, if it's a symmetry, remember symmetry. This is the peak, right? The highest peak. This is the top, okay. The left and the right must be same, balance. So I'm using the balance side, symmetry side, to comment about the spread. Usually this is the mean. Everyone, you know mean, right? So I'm going to use this mu. Do you all remember what's mu? What is this called? Can someone type? What is this symbol name? I want to see who can remember. Who Bun Chen say population mean? Bun Chen Dong Ho. I think many of you remember population mean. What is the name? What's the name? Mu. It's like a U shape. Mu is a population. Remember, population is a big group, right? Sample is a small group. So we talk about big group population mean here. So what is called spread? So if let's say this is your mean now, so I'm going to draw a few points. Let's say this is x1, x2, x3. There are many data in be 10 data or 20 data or 100 data or millions of data. So x1, 2, 3, 4, 5, 6, 10, 20, and so on. You draw yourself up. I'll just draw a few points here. So what's the purpose I draw all these points? Okay, I'm going to explain to you what's called spread. Spread means how far is each point from the, measure from where? Measure from the middle value, from the mean. See, I measure from the mean. x1 measure from the mean. This is the distance. x2 measure from the mean. x3 measure from the mean. x4 measure from the mean. x5 here. x6, x7, and so on. One by one, I find the what? Difference, meaning that x1 minus the mean. I take x1 minus the mean. Okay, and then x2 minus the mean. I plus off. Then x3 minus the mean. One by one. And then I square it up to the last xn. You have 10, then you do one by one until 10. If you have 100, you do one by one until 100. And then you square it, you total up the difference. Okay, and then you divide by the sample, by the number of the data. So I'll just explain to you the concept first, okay? I haven't gone through the full formula. So this is called spread. Spread means how far it is from the center point, mean, for each data. So the larger the spread, when you calculate all this, okay, you find that the spread is big, the value is big. Let's say example, you calculate one, the spread is 3.2, and another one you calculate after you total up everything is, let's say, 4.7. So which one is bigger spread? Of course 4.7, right? So you based on the calculation value, you can say which one is bigger. So the bigger value means the larger the dispersions. And is it good? It's not good. We must have a smaller dispersion. In research, in our project, if you want to compare whether these two data are, which one is better, you must see the dispersion. The smaller, the better. The bigger dispersion, not so good. So if you come back to this example again, sales department and production department, everyone, you see the mean, median, and mode is the same, right? You cannot comment based on the mean, mode, and median already because all are same one. So what to comment? You cannot comment already. And yet they are different. So how to check the difference? This is the one that you have to check. Use what? Dispersion. And what are they? So we're going to study now range, QD, variance, standard deviation, and CV one by one. Okay? So if you're ready here, I will start with the first one, range, the easiest. Okay, number one, range. Now I'm talking about raw data first. Raw data. What's range? It's the difference between the largest and the smallest in the data set. So for example, okay, this is a formula, largest minus the smallest, very easy, okay, for raw data. So let's say this is the, how many data here? Okay, and the largest is 45, the smallest is 10. So you must arrange from small to big, because largest is 45 minus the smallest 10 is 35. Any questions from anyone? So we start with the easiest range for raw data. Okay, and then for group data, remember group data has this what? Frequency. Remember frequency? This table, frequency distribution table. Okay, and then we also have learned about discrete and continuous. Am I right? I hope after holiday everyone still remember. If you manage to find some time to do a revision, it's good. So discrete data for group, there is a gap. Remember 1920, 29, 30, there's a gap one, correct or not? So a lot of times when we calculate the value or draw histogram, we need to close the gap. Remember plus minus 0.5. Okay, for discrete, no need one. Discrete is like this, less than 6, 6, 12, 12. It's a very small gap, so we ignore it by using the inequalities. Okay, so for group data, discrete, the range, is upper class limit of the last class minus the lower class limit of the first class. You also remember the difference between class limit and class boundary? Do you also remember or not? For class limit, discrete data, if there's a gap, we use the class limit. Okay, but for calculation and so on, draw histogram or draw object, we must use what? Class boundary. Am I right? Remember histogram, object, your x-axis is all class boundary here. All these are what? Class boundary. Remember? The frequency is the y mark. I hope you all do keep on doing your revisions. Okay, but for range, the surprisingly is finding the for group data discrete, you no need to use class boundary. You can use class limit, which means you no need to plus minus 0.5, something like you want to find the midpoint. Remember everyone, how to find midpoint? Upper plus lower divided by 2. Same, you can use for class limit or you can use for boundary for group data. Do you remember? Check your formula again, check your notes. So based on this example, this is the output of 80 workers in a factory. You see, total here, we have 80 here. So this is the output. I see there's a gap. We no need to close the gap. We take the upper class limit of the last class. What's the meaning last class? This is your last first class, second, third, fourth, fifth, sixth, right? Your last class, upper class limit, which is 69, See? Minus the lower class of the first class. The first class is here, the lower class limit is 10. So 69 minus 70 is 59, no? Without changing the class boundary. So no need use class boundary, or in other words, you no need to plus minus 0.5, everyone. That's why I asked you just now, do you know the difference between class limit and class boundary? Anyone still don't know? Oh, very quiet. I hope everyone know. Okay. So for continuous one, remember continuous, there is no gap one, right? 6, 6, 12, 12, no gap. No issue. We can use the class boundary, because remember for continuous group data, whether is we put the less than sign or not, we can straight away ignore it, right? 0 to 6, 6 to 12, and so on. So no issue for histogram and object, correct or not? So we can call this class limit also as the class boundary. Am I right, everyone? So for the range, no issue. Upper class boundary, or you can say upper class limit also can. Of the class, last class again is 30, last class one, minus the lower class boundary of the first class, which is 0 here. So 30 minus 0 is 30, Okay, this is for the time spent by students in the campus per week. So for range, whether it's a raw data or group data, not very difficult. You just take the highest minus the lowest, but you have to be careful a bit for the group data. Okay. Go on. Now, what's the advantage of range? What is the good thing of range? It is very easy to understand, and it's very simple to calculate. Just take the largest minus the smallest. Okay, that's the advantage. Now, I ask everyone here, do you think range is a good measurement to check this question? The answer is not really. So the disadvantage, since only the largest and the smallest are considered. You see, every time when you want to find the range, what do? You find the largest minus the lowest, whether it's a raw data or group data, that's it. The other data you see here, go back to this example. This example, we never touch one. This data we never touch. We only take the highest minus the lowest. So is it good? No. What are all these data in the middle here? You cannot just ignore them. Something like not exists. So it's not so good. We always take the largest minus the lowest. See here? Since only the largest and the smallest are considered, the rest of the data we don't care, right? It can be very much influenced by them, especially if they are unrepresented extreme values. Remember what is extreme value? How many of you remember? In chapter 2a, we learned about the advantage and disadvantage of what mean, median, and mode, right? Let's say I give you a data 2, 5, 10, 12, and suddenly I have 500. Remember this example? 2, 5, 10, 12 are very small number, right? Suddenly, this is what? 500. This is a extreme value. Everybody remember this? Because of 500, what happened to your mean? Affected, right? If you have extreme value, better use what? Median. Correct, not everyone? So in this case, if I have 2, 5, 10, 12, and 500, if you tell me what's the range, what's the range here? 500 minus 2 is what? 498. Correct or not, everyone? Okay. And what happened to all this small data? It's not significant, 5, 10, 12 compared to 498. It's totally nothing. Why? Because of 500 Too extreme already. So all the mean value, all the range, we call it the significance of the dispersion measured by range is useless already, unless we have a data like 2, 5, okay, compared to let's say 2, 5, 10, 12, and then 13. 2, 5, 10, 12, 13. This is better, isn't it? Because there's no extreme. So you can take the range 13 minus 2 is what? 11, right? Compared to this 498, definitely this one got problem. There's a issue there. Then sometimes question will ask you all what is the problem in this example they ask you. So you must know how to comment about the extreme value. Alright, you have done some in the tutorial questions. Oh, okay, I go on. Okay, done number 1. So let's go to number 2, quartile deviation, QD. Anyone need me to repeat again? If you need help, you just voice out. I can repeat. If I'm too fast, you cannot see my handwriting. Sorry for that. Okay, QD, or we call it this number 2, semi-interquartile range. Semi means what? Half. So basically, when we find the QD, we have to divide by 2. Quartile deviation, the other way is called semi-interquartile range. So interquartile range is given by IQR. Remember all the short name. Okay. So the disadvantage of the range, now just now we know that range got weakness. So to overcome this extreme value, we have what? The disadvantage of the range can be overcome by ignoring the extreme value. So this can be done by ignoring the top and the bottom quarters. So you see the top and the bottom quarters quarter means 1/4, and considering only the range between the quartiles, which means we take when we talk about quartile now, then you know there are 4 parts of quartile. Okay, so we only take the range between the quartile 3, Q3, and Q1, first quartile, and that's called interquartile range, IQR, the short form. So let me explain to you now what is Q1, Q2, Q3, and Q4. Everyone, ready? Now, I'm not sure how many of you have seen this before. So let me just explain the beginning, the concept first. After this, everyone can have a same face. And then when you have this type of questions, you can recall back what is called Q1, Q2, Q3, and Q4. If the quartile range is divided by 2, the figure obtained is called the quartile deviation. What we call it, divided by 2. Here, Q3 minus Q1, which is our IQR, you divide by 2, then we call that quartile deviation, which is our QD. Or the other name is called semi-interquartile range. Now, when you do your tutorial or you do your test, whatever, if the question mentioned quartile deviation, then you know it's what? Q3 minus Q1 divided by 2. But sometimes the examiner, they don't use the word quartile deviation. They use the word semi-interquartile range. It's the same. You still take the same formula. Okay, everyone, take note. So I want to explain to you now what is called Q1 and Q3. Okay, go back to our definition now. The first quartile, so the name for Q1 is called first quartile. First means Q1. See the one there? The underscore means first quartile, or we call it lower quartile. Again, some textbook, some exam questions, they don't mention first quartile. They mention lower quartile. Same meaning, Q1. It is defined as the value of an item 1/4. 1/4 means 1/4, or we call it 0.25 through the distributions. Okay, now let me explain to you, everyone. You draw one line starting from 0 to 100, right or not? Then I divide them into 4 parts. Can you tell me what is this? 25%, which is 1/4. Agree or not? 25%, total is 100 ma. First part, this is the first quartile. Quartile means 1/4, 25%. So this is your Q1. 0.25 lah. So the next one, this is what, 50%. 50% is what? Can I ask someone to give me the name for 50%? Which you have learned already? Yes, Boon Chen, you are right. Median. Oh, everyone? I say that you have learned before. Why? Because 50% is the middle, right? So that's called half lah, half. And this is your Q2, which is also called median. Oh, remember? I hope you still know how to comment median, right? 50%, another 50%, right or not? And the third part, which is 75%, or we call it 3/4. Right? This is Q3. So the third quartile, or we call it upper quartile. So we use the symbol Q3. It's defined as the item of 3/4, 3/4 lah, or 0.75 through the distributions. So to overcome the problem by the range affected by extreme value. Now the extreme value is here, not your range. Remember, to find the range, we take the highest minus the lowest. Not. If your extreme value is the largest, then your range will be not accurate. So to avoid that, we use what? Quartiles. So quartiles is the difference between Q3 minus Q1. So we avoid the extreme value. Can you see or not? We don't take the largest and the lowest. We take the bottom, avoid the extreme one. We take the half of this first quartile and the half of the lower quartile, which is Q3 and Q1, and then we minus it. So that's called IQR. Okay, see, quartile divides into 4 equal parts, 1, 2, 3, 4. With the quartiles now, we can say that the quartile of the observations lies below the first quartile here, and then another quartile lies above the third quartile here. This is the first. So half between the two quartiles. Half here is median between these two quartiles, Q1 and Q3. Can? So everyone know why we need to learn QD, because the range is not good, not perfect, because of the extreme value. Okay, but why there only Q1 and Q3 but no Q2? So for Q2, similar to the median, you see? Similar to median, I already mentioned here. So to find the Q2, basically this is what? Similar to median. So we don't touch this anymore in this chapter. You all can refer back to chapter 2A. So that's why the question asks why there's no Q2. Q2 actually is learned already. So skip the Q2 now. Forget it. Let's focus on Q1 and Q3. So again, there are raw data and group data. Do you still remember how to find median, everyone? Using the formula? N/2, isn't it? For median is N/2 for group data. For ungroup is N plus 1/2. Do you remember, right? So if you remember median now, then you can remember Q1 and Q3. The only difference is Q1 is N/4. Q3 is 3N/4. We talk about group data. For ungroup, we just plus 1. Okay, now everyone? Okay, so we start now. Let's look at the raw data first for Q1 and Q3 together. Now, same like your median, arrange the data in ascending, means from small to bigger. You have to arrange up, right? Okay. After that, what do? You find the, like the median, you find the location, right? Same thing for Q1 and Q3, you must find the location. Now, let's look at raw data, n plus 1 over 4. This is the location for Q1. Location for Q3 is n plus 1 over 4, you times 3. As I mentioned here, is 75%. Okay, can so n again is the number of items. Right, now let's look at the simple example for raw data. We arrange 2, 9, 13. Arrange first, and then find the quartiles. Number 2, in the quartile. Number 3, the QD. So let's start. There are altogether 7 numbers here, and 7. Arrange, so 2, 3, 5, 9, 13, 14, 17. Arrange first, okay. And then let's find the Q1 locations. N plus 1, so n is 7 plus 1, which is 8. Divided by 4 is what? Second item. Second item is number 1, number 2. 1 and 2. So what is the Q1? The value is 3. Am I right? Okay, let's find the Q3. So 3 multiply n plus 1 over 4. Okay, so we have 8 divided by 4 is 2 times 3 is 6. 6 items, 1, 2, 3, 4, 5, 6. So the value is 14. Anyone cannot follow? Okay, something like your median. Go back to a median. You want to find the raw data first. The median locations n plus 1 over 2. But now we talk about over 4 because of quartiles. Then IQR, Q3, 14 minus the 3. So we have what? 11, right? And then number 3, find the quartile deviation. Q3 minus Q1, which is 11 divided by 2. So you have 5.5. Can everyone? You let me know if I'm too fast. So n plus 1 over 4 and 3n plus 1 over 4 times 3. Okay. Can I give you 15 seconds? You try this example for me. Okay, everyone. Now, if you look at this example, n is what? 7 here. So take note. So if you have the n is odd number, 7 is odd number, right? Odd number. Remember in the median, also we have n can be odd number or even number. So if you, let's say 7 plus 1 is 8, 8 divided by 4, you get the round number. Location is round, so you can find the exact value for Q1, Q2, and Q3, correct? But if you have n in this example, there are 10 factory workers, so the n is what? Data 10. Sorry, this is what? Even number. Remember median. If you have even number, what do you do? How to find the median? Chapter 2a. Arrange first, okay, and then to find the location, you must take the half of what? Between the two location, remember? So for this quarter 1 and quarter 3 is the same method. Let's look at here. 20, 25, 26, this is already arranged. Okay, already arranged. So let's find Q1. Q1, as we know, is n plus 1, right? So n is 10 plus 1 divided by 4. Somebody calculate 11 divided by 4 is how much? 2.75, right? Am I right? Hang Lee. Okay. Ongket, you asked me how to get 3 and 14. All right, let's look at here. 2.75, because this is not a round number, 2.75. So between 2 and 3, 2.75, you see, this is 1, this is 2, this is 3. 2.75 is between what? Between 2 and 3. So this one right here, value of second item plus 2 here refer to the value of second item. Then the 0.75, you have to plus the 0.75, you have to times, then you find the difference between the value of third item and the value of second item. The difference means you have to minus it. Anyone don't understand? Okay, you see how we do it. So 2.75 is between the value of second and third item. So we take the value of 2, which is what? 1 and 2, 25. Arrange first, plus the 0.75 here, you must times the difference between value of third item, which is what? 26, minus the value of second item, which is what? 25. So 26 minus 25 is 1 times 0.75. You get 0.75 plus 25. So 25.75. Okay, not everyone? We just saw happen here, 26 minus 25 is 1. Other than that, if you have other different type of data, got 0.4 and so on, then the value here will be different already. Just use whatever location we have. Doesn't matter whether it's a round number or 0.4. Okay, you just make sure you arrange your data. And then if your n is even number, you have to use this method. This method is called differencing method. Okay, but if your n is odd number, no issue. No issue because plus 1 divided by 4 or first quarter or 3 quarter also no issue. Okay, we try Q3. Same thing, value of the 3 multiplied n plus 1. So 2.75 times 3, you should get 8.25, right? So 8.25 is between your data, you arrange 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Altogether got 10 data. So 8.25 is between 8 and 9. So 8.25 means the value of 8 item, which is what? 1, 2, 3, 4, 5, 6, 7, 8, 38. Then the balance of 0.25, what should we do? We take the 0.25 times the value of 9 item minus the value of 8 item, which means the difference between 8 and 9. Value of 9 item is what? 40 minus the 8, which is 38. So times 0.25. 0.5 plus 38, you get 38.5. Yes, Xuan Chong. Yong Xuan Chong. Yes, this is the formula. This is the formula for Q1, we take, no, we look at this point form, 0.25, 0.75, okay. Follow the value, the point form. So the formula, I mentioned here, the formula means based on the decimal point here, 0.75. So here is 0.75. If this is 0.25, means 0.25. If you get other, usually divide by 4, you either get 0.75 and 0.25 long. So you try and see the other number. So the difference is important. You must see between which number, which item number minus which item number. Can everyone? So after you find the Q1, Q3, can we find the interquartile range? So we take 38.5 minus 25.75. What do you get? $12.75. Then what's the quartile deviation? Divided by 2. Can Alright, so this is for raw data. Okay. I hope you all remember now, Q1, Q2, and Q3. Okay, don't mix up. Okay, for group data, do you still remember how to find median for group data? For group data, we don't have +1. Remember, for median, we use what? The median location, I write down here as a recall. Median location is n/2, right? For group. Group. So there's no +1. So for Q1, Q3 also same thing. We find the after arranging in ascending order, the Q1 location is n/4. You see, Q3 is 3n/4. There's no more +1. Right now, for median location, for median, calculate the median. The formula is what? Median. I write here, everyone. Q2 is what? Given by Lm plus what? C divided by frequency of the median times n/2, right? n/2 minus the total of what? Fn minus 1. The cumulative, do you still remember CF, everyone? Cumulative frequency, isn't it? Before the median class m minus 1. So if you remember the median concept, you can bring this back to find our actual Q1 and Q3. Now, also, if you don't want to use this median formula to find the median, we can also use ogive. I just go through quickly. Remember when you draw the ogive, everyone? Hello, can you see my picture? Can someone answer me? Can you see my picture here?
Can.
Too small or whatever, you let me know. So remember when you draw ogive, this is your CF, right? You remember the table, CF table. Then this is your class boundary. Then this is your ogive, right? Always go out 1. How to find the median? You find n/2 here, right? Then what do? You draw here, touch your ogive, you draw down. This is your median, betul. So to find Q1, Q3, you also can use formula. This is your formula. Remember, this is called what? Interpolation formula. And we also can use ogive, like your median. So my advice to everyone, you want to learn, if you remember median, you remember also for Q1 and Q3. If you cannot remember median, then you have trouble for Q1 and Q3. There are 3 adik-beradik. Call them brothers. You know one, you know all. You don't know how to do for one, everything also cannot do. So let's look at the interpolation formula for Q1, Q3. You check you compare with the Q2, similar one. So for Q1, LQ1, this is the lower class boundary of Q1. For LQ3 means lower class boundary for Q3. Remember, we use class boundary, not class limit. Why? Because for group data, if there's a gap, what should you do? Plus minus 0.5 or so I'm not going to repeat that. Boundary means you have to check whether there's a gap or no gap. For the continuous one, no issue. Okay, then plus CQ1 over FQ1. What is CQ1? Class size. Like this one, C is a class median. Okay, and then for the LQ3 is CQ3 divided by FQ3. It's the same one actually, you see. Just the Q1 and Q3 different symbol only. One for first quartile, 3 means for third quartile. Okay. Now, times this one n over 4. This one is times 3n over 4 because the quartile for the median is n over 2. Okay, then minus, this is your total cumulative frequency. Q1 minus 1 means the precedings before the Q1 plus, and this one is total FQ3 minus 1. Cumulative before the Q3 class. Can? All right. So you know Q1, Q3 already, right? We do one formula, one example now, based on these productions. So this is the units: 17, 30 to 17, 18 to 22. This is the frequency. Okay. Find the quartile deviation using formula. So you need to find what Q1 and Q3 using formula, and the second method using OJEF. So do you still have graph paper? Okay, we do that now. So can I ask everyone here, is there a gap? Yes. Remember, if there's a gap, you must close the gap. So this is your class limit production, class limit. You cannot use already. You must change to what? Class boundaries. Plus minus 0.5, and there is no more gap here. So this is your frequency. Can I give you all 10 seconds? Fill up all this box. And you see there's another, like the median. You need to build one more column here for what? CF, right? You know how to do plus and so on. So this cumulative here will be same as your total frequency, right? The last cumulative, 62. Okay, can you fill up all this? Okay, I suppose everyone already have done that. Anyway, I also want to fill up this. 27. Okay, 34. Done. Okay. So let's find the Q1. This is group data. So let's find the Q1 based on this N04, Q3 based on this 3N04 location. So do you still remember why we have to build this CF column here? Like the median, we have to check the location. So let's look at the Q1 first. the value of the Q1 is n over 4, where n is the total of frequency, remember? So 62 divided by 4. Calculator, 15.5, right? So 15.5, group data, how do you know? You must know your Q1 class, why not? Remember, Raymond, in exam, you must do these three things. Write down the Q1 location. Step 2, write down the Q1 class. And then step 3, calculate the Q1, use the formula. Same for median, same for Q3. Got marks given one. Anyone to understand? So 15.5 is the location. So where is 15.5? This is where the CF column plays the role. 15.5 looks at the first number, which is more than 15.5 is 24, right? So Q1 is here. You can say lies here. So this is your Q1 class, 17.5 to 22.5. You must write down, marks will be given. Okay, step 3, then you find the actual Q1. Use this formula. LQ1 plus LQ1 is the lower class boundary, 17.5 plus the class size. Still remember, upper minus lower is 5, divided by 22. 22 is your class of the, frequency of the Q1, which is 22. Then times 15.5 minus, how do you get 2? 2 is this one. Before the Q1, this is your total of FQ1 minus 1. Remember, this is the cumulative before the Q1 class. Yeah. So calculator plus times divide, you get 20.57. Make sure it's between this range. Enough, everyone. Okay, now I give you the chance, everyone, to do for Q3. So step 1, find the Q3 location. Q2, step 2, write down the Q3 class. And step 3, calculate the Q3. Anyone got the answer? So, what is the location for the 6.5? And what is the Q3 class? So you have to look at the CF column for the 6.5, which is the number more than 46.5 is 48, right? So you can just mark here Q3 lies in this, what do you call that? Class boundary, 27.5 to 32.5. So what's your Q3 based on the formula here? So LQ3 plus CQ3 and so on. The lower class boundary is 27.5 plus the class size is 5 divided by the frequency, which is the 14. 14 divided by 46.5, 3n over 4 minus the cumulative before, this is 34, right? Before the quartile 3 class. So minus 34. Okay. What do you get? Am I right? Can someone answer me? 31.96. Okay, Qingyi, where is the problem? Minyan selling, am I right? 31.96. Correct. So Qingyi, what is the bracket part? Oh, the bracket part here. This is the formula. You see the formula here. 3n over 4 is what? Here, 46.5. This is your 3n over 4. 46.5. So you put here lah, minus. What is this? Cumulative FQ3. So you must look at your CF now. Lor. Oh, before the Q3 class, just now we say what 48 here, right? Before means, you see I circle 34. Okay, FQ3 minus 1 is the CF. Remember, everyone must know the difference between cumulative and frequency. Don't choose the wrong column. Okay, so what's the quartile deviation? Q3 minus Q1 divided by 2. So you take the 31.96 minus 20.57 divided by 2. So what's the answer? .7 now. Okay. So any more of you still cannot understand? You can let me know. Yeah, so I will go for one more part here. Now, remember you draw ogive to determine the median. I already show you here, right? Okay, find the n over 2, then draw one line, touch ogive, you draw down, that is your median. So for Q1, Q3 is the same. The only difference is for Q1, you have to find n over 4. For Q3, you have to determine 3n over 4. Okay, everyone. So this is the less than ogive production of factory for 62 days. Okay, we use back this table. So do you still remember how to use this upper boundary and the CF? Can everyone draw here? Where you want to put? Here. Can I put here, everyone? Remember the less than CF table? Can everyone can see or not? So this is the production units. This is the CF, right? So what do you put here? Upper boundary. So I start with what? 17.5. 22.5 and so on. So you all may do it first. $17.5 we have 2, 24. Then we have 34. Yeah, so we have to do until the last one, 52.5, which is 62. So you do until the last one, 52.5, which is 62 here. Oh, yeah, you do yourself. Right, but you need to start from 0, right? Remember, CF must start from 0. Everyone remember this? So what do you add here? 5, right? So minus 5 is 12.5. So you must start from the upper boundary, 12.5, which you can see here. Start from 0. Then 17.5, 22.5, and then you choose the scale here, maybe 2 cm or 5 units. This one 10, 10, 10. So you can put 2 cm to represent 10 units. Oh, okay, so you draw already, Can later you can use your graph paper and redraw again everything. Then let's estimate the Q1 and Q3. Anyone cannot follow? Keep quiet means everything okay, still no issue, right? So this is our labeling title. So from less than object Q1, so we know the Q1 is N/4, which is what? 15.5, right? 15.5. So 15.5, you have to check here. 15.5 is somewhere around here. Let's say. So you need to draw your object. Then you draw touch here. Then you draw down here. It's around 20.6. Anyone draw object later from the graph is 20.6. Our calculation here is what? 20.57. Remember I said the graph and the calculation is bound to be slightly different because calculation can give us 2 or more decimal point, but graph will be very good if you have 1 decimal point. Not too much different. Now, how do you comment about the median? You still remember comment median? 50% of what less than or equal to whatever value, right? And another 50% is more than or equal to the value. But for Q1, now Q1, see the Q1, go back to this again. Your Q1 is 25%, right? So you must mention this 25% less than or equal. And another from here to here is what? 75%. This is 25, this is 75. You see or not, everyone? Okay, so when you want to comment Q1, you must mention 25% here, this is less than. And another 75% here, this is more.
Teacher.
Yes.
Somebody is open the mic so noisy.
One Emily. Who on the mic? Sorry, anyone on the mic? Xin Yi there.
Just now I say have the but somebody open the mic.
Yeah, I try
so
to check.
noisy.
I can't see anyone here. Hakim, Hakim, are you there? Anyone call Hakim? Yeah, Abdul Hakim. Yes, Hakim. Yeah, I saw your mic on. Abdul Hakim, are you there? Don't mind.
Yes.
Off the mic lah. Off your mic. Can lah. All right, very good. So this is what I mean, everyone. Bring your earphone so that you all listen tenderly during lecture or tutorial. If everyone on the mic, habis in the tutorial room or lecture hall. Okay, let's go back here. So when we want to comment this Q1, see, shows that 25% of the days are having less than or equal to 20.6, and another 75%, total must be 100, so another 75% are having production more than or equal to 20.6. Can? All right, let's look at the Q3. Q3, the location is 3N/4, right? 3N/4 is about 46.5. So 46.5, you know what to do, from the CF. Here, 46.5 is somewhere around here. From your graph, so you draw one line here, touch this, and then what's the answer? 32. Anyone get 32 from your actual graph paper? Our calculation is about 31.96, right? The graph is 32, almost there. So if you want to interpret Q3, Q3 the other way around, terbalik. Okay, we start with 75% because Q3 ma. Let's go back to this diagram again. Here, Q3, 75% here and 25% here. Terbalik already. So 75% here is what? Less than or equal to 32. And the balance is 25% is having more or equal to 32. Terbalik already. Okay, everyone, don't interpret wrongly. So the quartile deviation here, I thought just now, based on the graph here, 32, based on the graph, this one, minus 20.6 divided by 2. Similar to our calculation. 5.7. It's about the same. Any questions from anyone? Now, you see, the advantages of quartile deviation, like range, right? Every measurement of dispersion that we are going to study got advantage and disadvantage. So remember just now the range, easy to calculate, but the extreme value problem. So we overcome that with quartile deviation. So the advantage of quartile deviation is can be computed even though the n values are not known. See, n value means even though we don't know the extreme, okay, the lowest and the largest we don't know, doesn't matter, open-ended. So we still can take the class boundary minus the class boundary, the first and the last. Even though the last and the first final figure we don't know is okay one, as long as we know the class boundary and it's not influenced by the extreme value. But the disadvantage is it is not fully representative as not based on all information available. So the problem with this QD is not all informations are used. So this is basically for those who do research in future, then you will know more about the disadvantage of median quartiles Q1 and Q3. Okay, so just leave it there for us. Fully representative means, as I said, remember in chapter 1 we talked about population. Let's do some quick revision. Population in a big group, right? We take 10%. This is your what? Sample. Remember the small group? So if you want to fully represent, you must represent every group in the population and take it as a sample. If one or two groups you never take it as a sample, then it's not fully representative. And when it's not fully representative, we call this one bias. Do you know what's called bias or not? What is this bias? Anyone haven't heard before? Bias means not fair. Not fair. When it's not fair, then your data distribution is always not good. Okay. So that one I will leave to in your future when you study more about these distributions and so on. All right. Okay. Now, just before we go on for the third one, we have done two, range and QD. So this one done, range, QD done. The third one is the variance. Can we take 5 minutes break? Everyone, 5 minutes break. And we will come back again for variance. Okay or not, everyone? Okay, see you later.